Hey, I'm Anfa. In this video I want to do a little breakdown of a shader I made in Godot, specifically in the Godot's visual shader editor. So what you see here is a plane with a texture, and the shader is doing all the animation, the glitching, the scan lines, the distortion. That looks kind of like TV syncing issues, analog TV, I mean. And there's also one more effect where the resolution of the, there it is, resolution of the texture drops for a while. So I want to show you how these effects were achieved. Let's make this smaller. Oh, this is the visual shader. It's applied to the material. It's a standard spatial type of shader, so we have all the usual outputs, though it's set to unlit mode or unshaded mode, and it's set to additive transparency. So it just renders on top of everything else and is being added. And this is used in, it can be used in scenes like here. Let me disable a cinematic preview. Yeah, so I'm placing these little banners here and there. So they're just, added on top of everything else. So it's like a holographic display. I mean, it's just a small thing. I'm not going deep into like, how does this work? What is this technology? So it's just a fun effect. Okay, so I started with just the nodes and only things I could do with blocks. So I started by grabbing the UV coordinates. Here they are. Here's the UV input. Taking them apart. So I'm separating the X, so it's the horizontal, from the Y, which is the vertical. I'm also using time as input. Time is a value that keeps increasing. It basically counts up with seconds that pass since the game started, which helps for creating animations. Actually, it's like one of a few ways to make animations, because of course you could have a custom value like this is a custom value. This is a time offset variable I've created, so-called uniform. And this allows me to have multiple banners across the map, and each one of them is going to have a different time offset, so the animations won't sync. I mean, you could make them sync, but you could also have them break apart. And actually, I have a little script that makes the animations not sync. Like when the banner is spawned, the animation has a randomized time offset given, which is going to appear here. And I'm pretty much just adding this to every time value I'm pulling for driving animations. Okay, so I'm bringing the time in. I'm adding the offset. I'm doing some things like I'm multiplying this time by this Y coordinate, which is vertical, by 1,000. And this gives me 1,000 iterations, like this gives me 1,000 more, like I can divide this into, darn, I'm using a sine function after that. And because I multiplied this by 1,000, this sine function is going to give me 1,000 cycles from the bottom to the top, which is basically how these scan lines are made. So there's 1,000 scan lines from top to bottom, and we can control the amount of them with this number. If we make it 10 scan lines, it's going to look like that. It's going to be 100. It's going to look like this. Now, these are, of course, animated because we are also adding the time factor to offset them. So first thing is we're taking the value, which we have here, and we are adding it on top of the time, which is multiplied by 80. So this 80 number is pretty much just telling us how fast these are scrolling. If I make it 0, then we are adding our scan lines to the time, which is multiplied by 0, so it's 0. So it's just our scan lines. Neat. I can make 1,000 of these, and you can see they are stationary. And we can add the time as a factor, and they're going to be slowly scrolling up. So I was just tweaking this, and, you know, maybe you'll find this more pleasing. I was going for some kind of faster motion, so 80 felt good. So afterwards, we're doing the sine function, which basically turns a straight function that's going from 0 to infinity into a oscillating function that goes between -1 and +1. This is something I never did. And this is a ceiling function, which clamps this sine wave down so it's not a square anymore. And instead, it's not a wave, it's not a squiggly thing, it's a square wave. Otherwise, if I didn't do that, I think I can, yeah. Otherwise, the sine wave shape would be visible here as squiggles. And I didn't want squiggles, I wanted, you know, sharp, square wavy thingy. Okay, now this output is also fed outwards. So here, I am taking the original coordinates, x, plugging it here. I have y, which is processed into these scan lines. And yeah, actually the y is unaffected. So there is no change in the vertical coordinates. So there is no distortion in the vertical direction. There's only distortion going in a horizontal direction. And here, I'm taking the original horizontal coordinate, and I'm adding the squiggles multiplied by a tiny amount. So if I cut this out and do 1, for example, I meant 1, you'll see that our scan lines are pure black. And that's because we're going so far with these scan lines that, look, they pretty much make us see double. So that's not what we want. As you see, as I'm making this number smaller and smaller, they are converging into a single image that is just, you know, slightly distorted. I'm going to paste the old value now. So, of course, this is all artistic decisions. You can tweak this depth as much as you want. Okay, so after that, we compose our coordinates x and y together. Now, in the UV coordinates, this is called U and V. So U is the horizontal coordinate, V is the vertical, and there's also W, which is the depth. They correspond to X, Y, and Z when you're talking about the spatial coordinates, but these are texture coordinates. So texture coordinates go Y, U, W. Sorry, they go U, V, W, and the spatial coordinates go X, Y, Z. But we don't have like special nodes that are just named differently. We just use regular vector2 and vector3 nodes to process that. Okay, after that, I'm passing these coordinates to a next effect. So I could just use this, and I'm going to just plug that in into our texture sampler, and this is it. That's everything. And this is how it looked in the beginning. But then I added another effect, because I wanted to add some more distortion, something that would be a little bit more interesting. And I've come up with this. So I am again taking the time input, or like the offset. Actually, this is not used here. This is used there. Yeah, so I'm taking the time offset so I have an animation. And then I am taking the UV coordinates y, which is the vertical space again, and I am adding this up to time. So what I have is this slow scrolling effect. And how fast it's scrolling is determined by this number. If I make this 1, it's going to be scrolling faster. I can make this scroll really fast, right? But I wanted this to be just once in a while thing, not all the time. So we are having this scrolling motion. Now I'm multiplying this effect by 1.5 just to make it the values larger. I think I was like, what if, yeah, what does this do? What if I make a huge number? Oh, okay. So this kind of Yeah, this makes my values like ramp up faster when it goes from bottom to top. Okay, anyway, we're putting this through a tangent function. If it was a sine function, we would see squiggles again, right? But the tan function, or tangent, produces a different kind of values, which is a really nice shape, and this really reminds me of the classic TV, you know, tracking errors, or like VHS even. And we have, you know, the coordinates going to the left, up to infinity, then snapping to the right and coming back. That's another effect I'm going to be describing, this resolution drop. All right, I'm going to paste back the old value, 1.5. So the tangent function is doing that. And now after that, we of course add this to our original coordinates. So this is our u and v, and we're just adding a tiny, tiny bit of that onto our horizontal coordinate, because the distortion is moving vertically, right? That's why we use the y coordinate, or v, vertical, to animate it, but actually we applied the distortion in the horizontal coordinate. As you can see, the image is being distorted left to right, not up and down. The distortion itself is animated up and down, but the distortion is applied left and right. Right, and then we put together the coordinates so we can put them forward. Okay, and after that there's yeah, I'm gonna leave this for the end. So what's more is, now, how do we actually render a texture? We need a texture sampler. Here is a texture node, which can take a sampler. And I believe I used the sampler because I had some more settings. Yeah, because I could set the filtering. And if you zoom in, I can enable linear, and you can see that the image gets a little bit like softer. I would have to disable the squiggles, but basically I wanted to not have any sharp, any smooth things going on. I wanted all of this to be sharp, you know, pixelated. So there is no like interpolating between pixels, texels actually, so elements in the texture. But there is MIP mapping, and the MIP mapping is important for the texture resolution effect, which is going on here. So you can see this texture node has a port called LOD, and this, if it stays at 0, it shows the full resolution texture, but if we make it a lot lower, it's going to show us a lower resolution texture. And what I'm doing here is I am taking the time input, of course applying the time offset, multiplying this by a tiny amount so that it grows up very small. Then I'm using a remainder, which is modulus. So this makes the whole time function snap into a sawtooth-like shape. It's just going from 0 to 1, and then resets to 0 again. A straight line. Then I'm pushing this through a curve texture, and I've created a little curve here that is a function which doesn't do anything until it does. And what it does here is it raises this number, the value, which I'm putting into the LOD socket. If I change this, you can see that the resolution of our texture is changing as well. And we are somewhere here on the value. Yep. So, you know, by affecting this, I'm also rounding it up. This is not necessary, but if we're not rounding it up, different resolution versions or MIP maps of this texture will be blended together, which I don't want. I want everything to be like, you know, sharp, pixelated, glitchy, broken. So this is how I animate the LOD property, making the texture resolution occasionally drop. It seems like something is resetting in the display or something, you know. Okay. There are some tiny things which are, oh yeah, here I'm applying the scan lines to brightness of the image as well. I can make this 0 and there is no scan line effect applied to the brightness, which just leaves us with this distortion, which is fine. But I think if we're adding a little bit of the scanline effect to the color, or it's called albedo here as well, then it like sells it more. And I like that. Okay, let's talk about the last effect, which was quite a different one. I'm gonna root it in so we can see it. These are the random glitches you can see. And they are quite interesting. That was fun to make. I was thinking about trying to, whip out a bunch of nodes and make it whole block layout, but I thought it's gonna be easier if I just start having some fun with actual shader code. And whoa, okay, I pasted a 0 here, which made the whole thing break. So Godot has this node called function. No, it's not a function. It's expression. It's expression. So you have an expression, which is basically you can create some shader code. You can give it inputs. You name them. You give it outputs. You name these, and if I call this, a simple pass-through shader would be output 0 equals input 0 and semicolon, because this is HLSL or something. Yeah, it's a shader language thingy. So I started with that, and then I started playing with other things. And what I've come up with is, well, okay, I'm hitting the middle mouse button to scroll, but if I hit the middle mouse button in a text field, it pastes this. So what I can do here is, for example, replace this with true and comment out the whole logic here. And then the effect will be applied all the time so we can see it better. Warning, it's going to be flashy and nasty. So what we have here is a gate low and gate high. Ah, that's the stuff. Yeah, so first I started having things like that. And what I do is I started with this, and I was like, take the X coordinate and make it something static. So we make make it like the Y coordinate. What would happen then? And it turned out it's a really cool effect because it kind of stretches the whole image and makes like every line look the same. I don't think I can explain the whole thing in any reasonable amount of time, but I'm going to explain the very basic things so it makes at least some sense. First thing is defining two variables, float variables, gate low and gate high. This is, my idea here is to select a region on the texture, basically determine a point between 0 and 1, semi-random pretty much, and determine 2 points. And then I'm going to apply my distortion only to something that is between those 2 points. That's why you have these blocks that could glitch out. Not everything, just blocks. And this is here. So if the UV coordinate Y, which is the vertical, is bigger than gate low, so we are above this variable, and logical operator, the same vertical coordinate is lower than gate high, so it's below this number, and also gate, which is this thing, is true, then we apply the effect. So you must remember that every single, this code is executed on the GPU for every single pixel on your screen. That's why it's called a fragment shader. In the old days, it was called pixel shader. Then they started calling it fragment. So this code is executed for every single pixel. So when I'm doing an if, it's not like an if for the whole thing. It's an if for every single pixel. So I can select which pixels I want to affect by this. And that does it. Let me make this gate always true so you can see what does the gate do. Oh, I need a semicolon, sorry. So the gate is adding some another random thing that just turns on the effect rarely. Otherwise, it's going to be going on all the time. So, and it's annoying. It seems like a very, very broken screen, and that's not very pleasant to look at. But with this gate, which is, we are taking the time, we're dividing it by a large number, so it's slowly dripping. We're adding a different time that is also slower, so they're kind of diverging. This is not just one, but 2 times we're using the time because I want to create something that has a non-repetitive pattern. Like we have 2 things that have different cycle lengths and they are going to interrupt each other. After that, I'm multiplying this and I'm doing a modulus operator for the whole thing, or the remainder. A remainder node would do this exact thing. So I'm calculating a division remainder for dividing this by 1. And if that remainder is larger than 0.98, then the gate variable is true. So there's pretty much like 2% chance that this effect will be on. If you like average, 100 years, 2% of the time the glitch effect will be on. And on top of that, we're also doing kind of the same semi-random thing. We take the time, multiply it by a different number, apply a sine wave so it's cycling. Then we multiply that by a bunch of things. Then we mod it between 0 and 1 so that it repeats and we actually get a value between 0 and 1 because we need some coordinate. So there's a whole bunch of pseudo-randomness going on. There is no real randomness. Real randomness is super expensive and it's only used for cryptography where it's still not real randomness unless you have a special hardware in your computer that can provide real randomness. Usually the randomness in computers is faked, especially if it's not necessary for security. And in visuals, randomness is always fake. So I'm faking randomness just by, taking the time, multiplying it by different things, doing a bunch of wacky math to land on a value that is going to be different and it's going to change unpredictably. And because we have 3 values that are changing unpredictably and all of them are required to make this thing tick, the results are very random. They appear to be very random. So yeah, what we do is we do a mix. If I commented all of this out, we could simply do uv.x and that would pass the whole thing verbatim. So there is no change being done whatsoever. But we're not doing that. I'm doing a mix, which is kind of like a blend operator. It takes 2 parameters, one of which is this thingy. Yeah? Yeah, it is. Right. Okay, so it's just a sine wave of mod. It's just a ramp going, sine wave of time. It's just a ramp going from 0 to 1 every second. Just going whoop, whoop, whoop. Actually, I can show this to you. If we just send this to the shader, you will see. Okay. Oh, but I also need to make this true. Wrong thing. Okay. So now the x coordinate. Okay, no, that's a bad idea. Yeah, that's not gonna look well. Gonna look right. Sorry. I would need to do this in a different shader or reroute some things. I want to do that. But this is just going from 0 to 1 over a second and going back. So I'm interpolating this with this, which is uvx, which is the original coordinate, and I'm applying a blending function. So if I just did 0.5 here, that would mean that I'm just setting the x coordinate, which is the horizontal one, to a time-based number, and I'm mixing that 50% with the original coordinate. At the start, I was just doing this all the time, not mixing it with the original coordinate, but that looked quite stiff. So mixing it with the original coordinate gave it some more randomness, random appearance and life. And then I'm changing this mixing factor. so that the angle shape of this distortion is changing as well. And I'm doing this by, again, doing the same thing, taking the time, multiplying it by some number, then I'm multiplying it by the gain low and gate high just to have some more randomness. And then I take a sine wave out of time, yeah. And then I take a remainder from the division of the whole thing by 1, which is giving me a convenient number between 0 and 1, which is 0% or 100% of blending between this static value or the original UV coordinate, which would be, you know, changing for a different pixel. And that's all. And if none of these things are true for each individual pixel, then I'm just returning the original coordinate, which means the effect is off. And I'm not affecting the Y coordinate at all. It's just being sent verbatim. So this expression node is taking in time, the UV coordinates, and it's outputting modified UV coordinates, which I'm just putting into the texture node, which samples my texture and makes it all do things. That's all. Thanks for watching. I hope you got inspired to make some shaders in Godot. Oh, and if you would like to join me in my task to create the awesome new open source multiplayer first-person shooter game called Liblast, then you can contact me or leave a comment. Whatever. See ya.